this example, we're going to look at radical functions through a graph and see how our radical function is represented in the graph and any transformation that occurred on our radical function to figure out what the equation is for our radical function represented by the graph. So in this case, we have this nice curvy graph, and this is a radical function. If you remember back a couple of lessons ago, we had the cubed root. So this is a cubed root of x. And the cubed root of x will give us kind of this, I don't know, this S kind of strange shaped graph. So I'm going to start out with this being the cubed root of x. And I know that too because if I'm looking at here, I could see that it has a rotation about the origin. So that kind of acts like an odd function. Like if I take this and rotate it, it would be the same values. So I know that this is a cubed root of x. The next thing I'm going to look at is I'm going to look at what the cubed root of x really does look like. So thinking about 0 cubed, give me 1 second, I gotta actually, 0 cubed would be 0. So if 0 was in the cubed root, we'd still get 0. So then, let's see, the next cubed is an 8. 5, 6, 7, 8. And that's going to be, so the cubed root of 8 is 2, so 2 here. So I only have 2 points that I could look at. I could look at this third point here, so 5. Oh, actually, it's off of here because I did not plan this so accordingly to grab that one. But we could kind of use these 2 points. It would be good to have a third point to see what's happening here, but I'm going to use these 2 points because that's what we have. All right. So, oh, and I have a third point. I have 1. So the cubed root of 1 is 1. So there we go. 1 cubed. There we go. Something like that. Nice drawing. So what we're looking at here is we still have it about the origin. So we haven't moved. We haven't transformed up or down. And again, this is an odd function because f of negative x does indeed equal negative f of x. So we are looking at an odd function. We're going to look at any horizontal vertical transformations. From the origin, I see that our origin did not move. I see that we are still rotating about the origin or 0, 0. So we don't have any vertical or horizontal translations. It is still symmetric about our origin. The next thing I'm going to look at is horizontal or vertical stretches. Well, with radicals, we only have a vertical stretch, and we do see that we do have a difference between our graphs. So let's just see, let's just try to figure out how we stretched. So 0 times 0 is going to be 0, that's a 0 stretch. But we are 1 here, and our next value here is 2. So our original function is 1, 1, but our new function is 1, 2. And again, a vertical stretch, we're going to be looking at the y. All right, that tells me we're probably multiplying by 2, but I want to make sure. So I'm going to go out here, and I'm going to see that 8, 2 has now become, let's see, this is 8, 4, I believe. That looks at 4, 1, 2, 3, yep. So it does look like we are multiplying 2 by my output, by my y's. So now looking at this, I know that f of x is equal to the cubed root of x. This is my parent function. We have no horizontal or vertical translations or translations. We don't move up or down. But we do multiply 2 to f of x. And I know that f of x is a cubed root of x. So I'm going to multiply that by the cubed root of x. and so that is my function. If I wanted to take it a little bit further and get it all in the Radicad, I could actually say this is a cubed root of 8x. Either or, I would probably take the expanded out. You don't have to simplify it even more into 8x, but just in case you did see it in this type of format. So there we have it. You're going to look at just different aspects of the graph, what makes that graph unique for the parent function, like a square root or a root to the power 4 would give, I don't know, I said a root to the power 4, the fourth root would give us a domain of 0 to whatever. So if that domain changes or the range changes of 0 to infinity, then that would suggest transformations. If your origin or if your domain is and range are still on 0, 0, then you're looking at a scaling factor. So again, here we go. We've just done that. And again, if you have questions, please feel free to ask. Just make sure you know the difference between the square roots and the cube roots and exactly how the cube roots are different than cubed functions. All right, so I will see you in the next video.